Hey yo, last one for chapter 6. We're doing part 2 of section 6.6. Now we're on to multiplication and division of complex numbers. Um, Not too complicated really. The big key to remember as we're doing these, distribute no differently than you would with an x or a y. However, whenever you end up with an I squared, it changes to a -1. That's the big key to remember here. So as we're going through these, just remember the distributive property. Treat I like it's an x. Just imagine it's an x until you get an I squared. So we carry through just like we normally would. 3 times 2 is my 6, and then here I just have a positive times a positive. I have 15i. I'm not changing anything unless I get an I times an I. Here I have a negative times a positive. 4i times 2 is 8i. And then my last one, I have a negative times a positive, so I have a negative. You got to make sure you're real careful with your signs, because I have a negative. 4 times 5 is 20, and that gives me I squared. The key here now is to know that that means I squared is -1. So in the long run, instead of subtracting 20i squared, you got to think of it as adding 20, because you have a 20 times -1. So you have a -20 minus a -20. So you're adding, and I'll move it up here. We have our 6, and then we have our 15i minus 8i is 7i. Then the way to think of this chunk is minus 20 times -1. So we have 6 plus 7i plus 20. So we have 26 plus 7i. Okay? So let's go down here. I don't know why they give us this one before this one, but example 14, as long as I wrote it down correctly from the book, this is all it is. So we're going to distribute the 2i. That gives us an 8i, positive, negative, so I have a minus 12i squared. Again, I'll go down here for this one. I squared, every time we see I squared, we change it to a -1. I'm going to do one extra step before I get to where the book is. We end up with 8i plus 12, because we have a -12 minus a negative. However, the book is simply going to flip them and write the imaginary number second. That's all you need to know for multiplication with complex numbers. So we're going to move to division. And division is where it gets a little more complicated, because we're back to, I'm going to say rationalize the denominator, because that's what you learned. That's what you want to link this to, is remember how you rationalized the denominator. We need to do something similar now, only we need to get rid of I. So example 17 gives us 2 plus I over 3 minus 2i. Okay, now kind of a goal is to end up with, if we can end up with a negative. If we can end up with a negative I squared, we know that we would have a -1, so we'd have 1. So negative I squared is a positive 1. That's something to kind of think. If we can do that, we end up with 1. The big key here, when they give us a complex number, and when we have I in the denominator, we want to make that I go away. You remember rationalizing the denominator when I mentioned, remember the a squared minus b squared rule, where you have plus or minus. Do the same route of thinking here. Take your 3 and take your 2i. That's not going to change. Those numbers will be the same. negate that. Make that the opposite. There it's a negative, 3 minus 2i. I'm going to multiply by 3 plus 2i. Whatever I do on the bottom, I do on the top. So when I do this, I'm taking this piece here, and I should have left myself a little more room, but I have my 3 times my 3. So I have 9. Well, then I have, I'll write it out. I have a plus 3, right here I have plus 3 times 2i, and then minus 2i times 3. They're gone. Positive 3 times 2i minus 3 times 2i. So that middle term goes away. My imaginary number goes away. I'm left with a minus 2 times a positive 2 is 4i squared. I'm good when I get an I squared. That's what I'm hoping for. Because when I get an I squared, it's a negative 1. But we'll go up to the top here. And now we're multiplying. 3 times 2 is 6. You can't get ahead of yourself and just assume the same thing's going to happen because their numerator is different. So we have 2 times 3 is 6, and then 2 times 2i is 4i, and then I have an I times 3 is 3i, and then a positive times a positive, so I have a positive. 2i times I is I squared. You can have I in the top. I'm going to take one extra step here. I'll go right down here. We have 6, that's our only actual number right now, plus 4i and 3i, so plus 7i, plus 2i squared is negative 1. Remember, I'm taking an extra step. You can change it up here. You automatically know that's a negative 2. I just want you to see everything. Here, I have a 9. Those cancel out. Minus 4 times my negative 1. So I actually have 6 minus 2. Minus 2 because the I squared turned into a negative 1. Down here I have 9, but then I have a negative 4 minus a negative 4. So 9 plus 4 is 13. And we'll do one more of these. In the book, for me, when we're doing these, I can't say in class anymore because we're done for this semester. When you're doing these digitally and you enter an answer, I'll be manually grading these. So if you enter that, I'm giving you full credit. That's the answer. You got the numerator and you have 13 in the denominator. I believe the book, I think I wrote it how the book split it. The book splits it to say we actually have 4/13 plus 7i over 13. And you could say 7/13i, but 7i over 13. They split it. You can leave it like that. I want to see that you did the work right to get, you got the right numerator and you got a number for the denominator. Okay, so don't get confused if we're working these on the board or you're working the problem sets at home. If you get this and the book splits them, all they're doing is splitting to say that as long as the denominator is the same, you can go ahead and split that fraction. Okay, so example 18 now. This is the last one we'll do. Example 18 gives us 7 minus 4i all over I. Now here is where the rule I mentioned earlier comes into play. We have an I. If we take I times I, we get our I squared. Well, if we have a negative, if we can multiply by a negative I, then we can have a negative I squared, which is a negative 1. So it gives us a positive. So here, I have I in the bottom. I want my I gone. I know that if I multiply by I get I squared and it's gone. But I can multiply by a negative I in this case. By doing so, I'm just going to slide down here. This is the last example I'm going to do. By doing so, I get a negative 7i, and then here I have a negative, and this is kind of tricky to think, but I have a negative 4, well, negative times a negative, so positive 4i squared. We'll just do it this way. I have a positive 4i squared. Probably the simplest way to think about it. You can always think of this as negative 1 times I. So positive 4i squared, but that's all over a negative I squared. So I have a negative 7i, and then I'm going to take one extra step again. This is the last one I'm doing. 4 times I squared is negative 1, I think. I think this is the last one. I'll double check. And then a negative I squared is a negative 1. That gives us our positive. So we have negative 7i minus 4 all over 1. And they still do change it. They're going to write the I last. So as you're doing these in the book, again, I'm looking for those. Honestly, on the test, I'll give credit if you have the right amounts, if you have the right numbers. The book is going to write negative 4 minus 7i. They're always going to put that complex number last. They're going to end with it. Either way, you're starting with a negative, but that's the answer. We got a 1 in the bottom, positive 1, because we multiplied our I times a negative I. When we do this step, I times negative I, we get a negative I squared, which is a negative 1, gives us that positive 1. Okay, that's it for section 6. That's multiplication and division with complex numbers. Again, not really difficult. This is the most complex thought process here. To get rid of the I in the bottom, you have to think, how do I get an I squared? And the goal is to try, if you can, try to get a negative I squared so it turns into positive 1. All right, let me know if you have questions. See you in a bit.